here. There we go. All right, so angles in a triangle. First, we have the triangle angle sum theorem. Okay, so the sum of the measures of the angles of a triangle are 180, right? Okay, so in the figure at the right, measure of angle A plus the measure of angle B plus the measure of angle C, all three together, have to equal 180 degrees. Okay, all three angles in your triangle are 180. So we're going to use that for numbers 1 and 2. We're going to find the missing angles. So for number 1, looking at triangle ABC. Okay, I have 2 angles of that triangle. I want to find this remaining one. So angle 1. So since all 3 of those have to be 180, I would just subtract the 2 that I already know. So 90 and 58 from 180. Okay, and that will be 32 degrees. Okay, and that's how to find angle 1. Okay, so just subtract those from 180. Now if I look at the next triangle here, I'm also looking for angle 2 and angle 3 in that same picture. Well, angle 1 and angle 2 are vertical angles. What do you know about those 2 angles? They're the same. So since angle 1 is 32 degrees, angle 2 is also 32 degrees. Now that I know what angle 2 is, I can find angle 3 because I'm given this other angle within my triangle. So to find angle 3 again, all 3 have to be 180. So I'll subtract the 2 I already know. Okay, so subtract 108 and 32 from 180. That's 40 degrees. Okay, and that would be angle 3. Okay, so just to make it look a little bit nicer, I would say the measure of angle 1, that's what that little m means, it's the measure of angle 1, is equal to 32 degrees. The measure of angle 2 is also 32 degrees. And the measure of angle 3 is 40 degrees. Okay, just so we have them all in one spot so it's easier to look at. Questions on 1? Okay, then looking at number 2. So I have triangle QSR. These little dashes in the angles mean that they are congruent or equal to each other. So since angle Q is 30 degrees, angle R is also 30 degrees. Okay, that's what those markers mean within your angle there. So now since I know my 2 angles, to find the third one, we just subtract from 180. Okay, so the measure of angle 1 is 120 degrees. Okay, questions on number 2? All right, then next we have the exterior angle theorem. So the last one was the triangle angle sum theorem, so that's all the interior angles of your triangle. Okay, now we're going to talk about the exterior angles of your triangle, so the angles on the outside. So the measure of an exterior angle of a triangle is equal to the sum of the measures of the 2 remote interior angles. Okay, so the sum of the remote interior angles. Sum meaning adding. Now, the remote interior angles in this triangle here, if my exterior angle is angle 1, right? That angle is on the outside of your triangle. It is exterior. The remote interiors would be angle B and angle A. Okay, those are remote interiors. Those are the 2 angles that are not next to your exterior. Okay, so I don't want angle C as part of that remote interior. That's the one next to your exterior. So the two not next to, you add together to get your exterior angle. Okay, so I would add together A and B to get the measure of angle 1. Okay, so you add A and B to get angle 1. So we're going to practice that in 3, 4, and 5. So number 3, we want to find the measure of angle 1. So first, that is an exterior angle, so I need to locate its remote interior angles. Okay, those are the two angles inside your triangle that are not next to the exterior. Okay, that would be angle X, which is 50, and angle Y is 65. Okay, so I want to add together those two remote interiors. So 65 plus 50 to get 115. That is the measure of angle 1. Okay, so I just add together those two remote interiors. Questions on 3? Okay, then looking at 4, I have to find the measure of angle 1 and the measure of angle 2. Now, it doesn't matter which you do first. I'm going to find angle 1 first. Okay, that's an exterior angle. Okay, so I need to locate its two remote interiors. The ones not next to it, that would be angle A and angle B. So to get angle 1, you're going to add 25 and 35. That's 60. Okay, then to get angle 2 is an interior angle. Okay, I know the other two interior angles in the triangle, so I can subtract those from 180 to get angle 2. And that's 120. Okay, so the measure of angle 2 is 120 degrees. Okay, questions on number 4? Questions on number 4? Okay, then looking at number 5. Does anybody remember what these arrows mean? Not equal. They're going the same way, meaning what? They're parallel. Okay? These arrows in your lines here mean that those two are parallel to each other. Okay, so the ones with the single arrow are parallel, and the ones with the double arrows are parallel here. Okay, so if these two lines are parallel, and I have a transversal, what do I know about my angles here? They're the same. Okay, why are they the same? They are alternate interior angles. Okay, so angle 60 degrees right here is going to be equal to angle 1 because they are alternate interior angles. Okay, same thing with angle 2 and this angle right here. Those are alternate interior angles. Since those lines are parallel, they are congruent. Okay, so I found angle 1 and 2. I have to find 3. What should I do to find angle 3? Add 60 and 60. Okay, those are your remote interior angles, and angle 3 is the exterior. You can do that too. So the measure of angle 1 was 60, measure of angle 2 was 60, and the measure of angle 3 is 120. Okay, questions? All right, then moving on here, we have some corollaries for our triangle angle sum theorem. Okay, the first one, the acute angles of a right triangle are complementary. Talk to each other. What does complementary mean? So, complementary means that you have two angles that add to 90 degrees. Shh, coming back here. Two angles that add to 90 degrees. That's what complementary means. So the acute angles of this right triangle would be A and B. So I can take the measure of angle A and add the measure of angle B, and it'll be 90 degrees. Okay, so you can take your two acute angles of a right triangle, add them together, they should be 90. Okay, the second corollary, there can be at most one right or obtuse angle in a triangle. You cannot have two right angles. You cannot have two obtuse angles within a triangle. If I have two right angles, your triangle doesn't make sense. Doesn't close. It's not a triangle. If I have two obtuse angles, again, doesn't close. Doesn't make sense. Okay, you can only have one right or one obtuse angle. So it's a good way to check if you did your math correctly. Questions on those before we do some more examples? All right, then, next problem here, we want to solve for the measure of angle 2 in this triangle. Okay, so we're looking for this angle right here. Well, with this picture, I'm given the exterior angle, right? And I know to get that exterior angle, I have to add together my two remote interior angles, right? So what should I do to get one of my remote interiors? You can subtract. Okay, so you can take your exterior angle of 92 and subtract one of your remote interiors to get the other remote interior angle. Okay, so the measure of angle 2 would be 21 degrees. Okay, questions on this one? All right, do number 20 right here really quick. Yeah, I know, it jumped to 20. Find the measure of angle 4 in this picture. All right, what's angle 4? What's angle 4? It is 33 degrees. Shh, quiet please. It is 33 degrees. So you can take 123 and subtract 90, since this angle here is 90 degrees, to get angle 4, which is 33. All right, next one right here, we're finding the measure of angle ABC. Okay, so angle ABC is this angle right here. So we need to find what that measure is. In order to find what that measure is, we have to solve for x. Well, I know I have an exterior angle of 148. I'm also given equations for the two remote interior angles. So we can still use that exterior angle theorem to solve for x. So I can take the measure of angle A and add angle B and set it equal to 148. Okay, so adding angle A is 2x minus 15 plus angle B. Angle B is x minus 5. And that'll be equal to your exterior angle, and that's 148. Okay, so you can add together your two remote interiors, set it equal to your exterior. Okay, so I'm going to add like terms. So we have 3x minus 20 equals 148. Add 20 to both sides of your equation. So we have 3x is equal to 168. Divide both sides by 3. To get x equals 56. Now that's not what I was looking for though. Okay, I had to find the measure of angle ABC. That's why I circled it here. So to find the measure of angle ABC, I need to plug in 56 for x. Okay, so we have 56 minus 5. So that angle is 51 degrees. Okay, so I had to find x. I had to plug x back in to get that angle. Questions on this problem right here? All right, do this one right here. Right here. Set up, solve for x, find the measure of that angle.
Figure out what angles are in order.
No, it's a message for you.
So if I do that here,
It's the end of the now. No. Yeah, you only get jump is an equivalent to like some of my team.
Don't mind it.
All right. So, if you're still working, that's fine. Keep going. Don't rush. Raise your hand. Don't shout it out. How would you set up an equation to solve for x in this one? Raise your hand. Raise your hand. Anybody? Emily.
2x plus 27 plus 2x minus 1.
Yes. Good. Okay, so adding together your two remote interiors to equal your exterior. From here, you solve for x. So I'm going to combine like terms here. I have 2x and 2x. That is 4x. 27 minus 11 is 16. Okay, now I can subtract 16 from both sides of that equal sign. So we have 4x is equal to 84. Divide both sides by 4. So x is 21. Now, I wanted you to find the measure of angle JKL. Okay, so if I go in order here, J to K to L, the angle formed there is this one. Okay, the angle formed with 3 letters, the vertice is always your middle letter. Okay, the vertice you're looking for is always that middle letter. So I'm looking for K. Okay, same thing in this one. I had ABC, so the vertex of your angle should be at point B. Okay, so here I would plug in 21 for x. So I have 2 times 21 minus 11. Okay, so that angle is 31 degrees. Questions on this problem here I had you do? All right, then the bottom triangles is just setting up an equation and solving for x, and then you want to classify the triangle. So classifying our triangle is what we did on Friday. So to classify a triangle by its angles, that would be obtuse, acute, right, and equiangular. Okay, so those are our different classifications by its angles. So first, we have to figure out what the angles are. So in this one, I'm given an equation for each of my angles. How could I set up a large equation, okay, to solve for x? What do all 3 of those angles have to equal? 180. So I would take each of those measures, add them together, set it equal to 180. Okay, make sure you have all 3, okay, all 3 added together to be 180. And again, you can combine like terms then. So 6x, 15x, and 4x. All add together to be 25x. I have 5 plus 1 minus 1. That's 5. And that's still equal to 180. Okay, I would subtract 5 from both sides. So I have 25x is equal to 175. Divide both sides by 25. X is 7. Now, if I want to classify this triangle by its angles, I would plug 7 in for x for all 3 of those. Okay, so I have 6 times 7 plus 5. That angle is 47 degrees. This top angle, I have 15 times 7 plus 1. That's 106 degrees. Okay, then here I have 4 times 7 minus 1. Okay, that's 27 degrees. Okay, I have one angle that is obtuse, so this would be classified as an obtuse triangle. Okay, questions on how I did that example? No? Yep.
How'd you get 106 or so many times 6?
From what?
15 times 7.
Oh, how did I get each of these? I plugged 7 in for x. So here I did 6 times 7 plus 5. So I just plugged that 7 in for that x value. And I did that for each one.
Okay.
Other questions?
I'm too stupid for this.
No, you're not. How you feeling? Good? Okay? About your angles in a triangle?